Hi, welcome to Watkins Waggles. We're still looking at C2 chemistry higher tier calculations in this video, and we're focusing on reacting masses. This is the calculation where you'll be asked to work out the mass of an element or a compound based on the mass of an element or compound that you're given in the question. The question format will always be a similar style. It will ask you to calculate the mass of, and then they'll give you a name of a chemical needed to produce the mass of another chemical. So they'll give you a mass in the question. They'll talk about two chemicals, and the clues will be that somewhere in the question there's going to be a balanced equation. It could be at the beginning of the question, could be part of a previous part of the question, and you're likely to be given the atomic mass or the molecular formula mass of some of the chemicals as well. So those will be your clues. We're looking for that word calculate, and it's always going to be 3 marks. Okay, so if the question is worth 3 marks and it talks about calculating a mass, this is the calculation you're going to need to do. The mnemonic for this one is called MAMRU with a triangle at the end, okay, because we're going to need to use our formula triangle that links mass, moles and MR. This formula triangle is in alphabetical order, just like the vaccination MMR that you might have. If you put these words in alphabetical order, mass, moles and MR, mass comes first, moles next, and then the R for MR comes after that. So that's the triangle we're going to need throughout today's calculation. The first thing is, this calculation is only higher tier, so if you're foundation tier, you can stop watching and go and be more productive. Right, how do we work it out? I'm going to use some past paper questions in order to help illustrate this. So if you want to work along with me and you want to be able to see the question more clearly, first of all, you're going to need the exam paper from 2013. Okay, so you're going to need the C2 higher paper from May 2013. Okay, you can download that from the AQA website or by finding it on Google. So here's the question. I've managed to spot the question because in this case it talks about calculating the mass of an element. Okay, it tells me the mass of another element. I've spotted that here because there's my calculate the mass when you want to make a certain known mass of something else. I've found the clues that I was expecting to see. I've got a balanced symbol equation, and I've also got the relative atomic masses given to me in the question. I then look at the number of marks just to confirm I'm about to do the right thing. There's my final clue. It's worth 3 marks. Okay, so I need my mnemonic, MAMRU. That's what we're going to do. But what does it actually require us to do? So the first thing is, the BE is for balanced equation. I need to pay attention to the chemicals I've been asked to talk about, and then from the balanced equation write down what I know. So BE, from the balanced equation, I've got ammonia and I've got nitrogen. I need to find those in the reaction. If you're following this on the question at home, you'll be able to see this more clearly, but it does tell me at the top, ammonia is produced from nitrogen and hydrogen. So if ammonia is produced, this must be the product over here. So this one is ammonia. I can recognise hydrogen, and there's the N for nitrogen. So I copy down exactly what it says in the question. So ammonia, it says 2NH3. The big numbers and the small numbers need to be written down. I'm then going to do the same for nitrogen. So I'm looking in the balanced equation, okay, and it tells me that it's just N2. So I'm going to write that down as well. So I copy down the big numbers and the small numbers from the question. The next thing I'm going to do, it says MAMRU. So like we've done before, if you've watched the video on empirical formula, the first bit, the MAM, stands for mass, atomic mass, work out the moles. Okay, that's what we're going to do next. So the mass, they've given me one of the masses in the question. They've told me that there is 6.8 tonnes of ammonia. So underneath ammonia, I can write 6.8. It's worth remembering that this question is in tonnes, but they've given me the unit, so at least I've not got to put that myself. Some questions will be in kilograms, some will be in grams. You've just got to watch out that if you're asked to write the unit, that you write it correctly. I don't know the mass yet of the nitrogen. That's what they've asked me to calculate. So the next thing I need to do is to write down the atomic masses. They've given me these in the question, so the atomic mass of hydrogen is 1 and the nitrogen is 14. At this point I need to pay attention to the little numbers that I've got in my formula, but I'm going to ignore any big numbers in front of it. So I just want the atomic or formula mass for the chemical. So we'll start with N2. N is 14, there's a little number 2, so that's 2 times the 14, which is 28. Okay, NH3, this is just your relative formula mass, what we call atom, so you add the atomic masses together. I've got 1 nitrogen, there's no number next to it, so it must mean 1, and 3 hydrogens. So I've got 1 14 and 3 1s. So I've got 14 plus 1 plus 1 plus 1, which is 17. Okay, so I've now worked out the formula mass of NH3 and I've worked out the mass of nitrogen. They weren't given to me in the question, so I'll get marks for working those out. Then I need to do the moles. So just like when we did MAMS, if I take the mass, divide it by my atomic or formula mass, I will end up with moles. I can find the same information from my formula triangle by making sure I've memorised that moles is mass divided by formula mass. So that's what I'm going to do next, and obviously I'm going to need my calculator. So I've got 6.8 divided by 17. If I wanted to be really clear about my working, I would write that down as an extra calculation. So 6.8 divided by 17, 0.4. Okay, and then I've got an unknown. I don't know what the mass is yet, what the number of moles are, because I haven't got 2 numbers to work with. So I then need to go back to the mnemonic, be MAMRU. This final R is for looking at the big numbers in our balanced equation, okay, and looking at the ratio of one chemical to another, because those big numbers are the same as the number of moles. So in our formula we've got 2 in front of NH3, but we haven't got a number in front of N2. If there's no number, it just means there's 1. So I've got 2 lots or 2 moles of NH3 compared to just 1 mole of nitrogen. So if I've got 2 moles of ammonia, this NH3, and I know that my mole is 0.4, I've got double the amount of this compared to this. So double the amount compared to here would mean I'd have to half this. So half of 0.4 is 0.2. Okay, so 2 lots of this combined with 1 lot of this. So I must make sure there's 2 lots compared to 1 lot. So all I've done is divide that number by 2 to get the number of moles of nitrogen. Then it says to use the triangle. Okay, so be MAMRU, use your triangle. Why can I use the triangle? Because now I've got the moles, I've got the MR, and I've been asked to calculate the mass. So all I need to do finally is moles times MR. The moles are here, 0.2, and I'm timesing it by 28 to give me the answer of 5.6. I'm just going to put that into my calculator again, 0.2 times 28, 5.6. And then what I need to do is just double check, does that sound like a sensible number? So they said 6.8 tons of ammonia, how much nitrogen would be needed? I'm taking nitrogen, I'm adding something else to it, so I'd expect to then make 6.8 tons, so I'd expect the number to be less than 6.8, and it is. So that seems like a sensible number, that's my answer, that's full marks. Here's a further couple of examples if you want to practice your calculating mass calculations. So remembering that the mnemonic we're going to use is be MAMRU, and now I'm using the 2012 paper. So again, it's C2 Higher Paper Chemistry. This one is May 2012. Again, you can find these online or get them from us. And this is the question. If you want to follow it yourself, you could obviously pause the video at this point and write that down. We've got a student adding water to calcium oxide to make calcium hydroxide. The equation for the reaction is shown below. We've got a balanced equation. That was one of our clues. You've been asked to calculate the maximum mass of calcium hydroxide, which could be made from 2.00 grams of calcium oxide, and you've been given some relative atomic masses. So in terms of revision, it's totally matching up to our reacting mass question style. It's asking us to calculate the mass of a named chemical. That's here. It's asking us to calculate the maximum mass of calcium hydroxide, and it's given us the mass of another chemical. So it's told us that we've got 2.00 grams of calcium oxide. The clues are all there. The clues are that there's a balanced equation. They sometimes give you the atomic masses, and that it's worth 3 marks. okay, we need to use B MAMRU. So first thing I'm going to write down on the side is B MAMRU, and then I'm just going to remind myself of my formula triangle. I might as well write that on my exam paper while I remember, so that I can use it for reference later on. So BE, balanced equation. I need to take the information they've told me to do from the balanced equation. They've talked to me about calcium hydroxide, and they've talked to me about calcium oxide. Again, at the first part of the question, they've told us that water is added to calcium oxide to make calcium hydroxide. I know that this arrow means to make, so this must be the calcium hydroxide. This is the calcium oxide, and there's the water in the middle. So calcium hydroxide, I copy it exactly from the balanced equation, big numbers and small numbers. And then the other chemical was calcium oxide. Again, I copy it exactly as they've put it in the balanced equation, both big numbers and small numbers. Then we're going back to the M for the mass. Okay, what masses have they given us? They're only going to give us one mass. They've told us there's 2.00 grams of calcium oxide. We don't know what this mass is yet. Atomic mass or formula mass. They haven't given us these in the question, so we're going to have to work it out. Calcium oxide, they've given us is 40 for the calcium, they've given it me here, plus 16 for the oxygen. That's 56. I can check it on my calculator just to make sure I'm not having a bit of a moment and getting it wrong. Perfect. Then I've got to do the formula mass for calcium oxide. So again, I've got one calcium, which is 40. I've then got brackets. So inside the bracket, I've got 16 plus 1. But that bracket has got a 2 outside it. So all of the bracket needs to be multiplied by 2. So I've got 40 plus 17 times 2, and 17 times 2 is 34. So this one is 74. Okay, again, I start getting marks here because I'm working out my formula masses. Then we're back to the M, working out moles. To work out the moles, we can use our formula triangle. Mass divided by MR. The mass of the calcium hydroxide we don't know yet. This one we do. So it's 2 divided by 56. So 2 divided by 56, here's our number of moles, is 0.035714. Okay, so we've got the number of moles, 0.035714, and again we're going on to the R for the ratios of the big numbers. Now when I copied it down, there weren't any big numbers in front of the two formula, so if there's no numbers that just means 1, that means there's one of these to one of these, that means there's 1 mole to 1 mole, but it's not 1 mole, it's 0.035714. Basically just means that if the numbers are the same, the number of moles are also the same. So I now know the moles of this one. So again, I've taken up quite a lot of room in my paper, but it doesn't matter as long as I'm clear on my working out. 35714, and now I've got the moles, which are here. I've got the MR, which is 74, so I can work out the mass. So moles times MR, so that's 0.035714 times by 74. Use my calculator. Gives me an answer of 2.642836. Now, just check it again. 0.035714. 0.035714 divided by 74. Wasn't divide, was it? It was times. Joys of being in the stress of an exam, you might have to go through the process a couple of times just to make sure you've got it right. That's my answer. So normally a science exam, you do it to 3 significant figures. So 2.64, I haven't got to round it up, so it's just 2.64 grams. Final check, does it make sense? How much calcium oxide could I make from 2 grams, calcium hydroxide could I make from 2 grams of calcium oxide? It makes sense that I could make 2.64 grams of calcium hydroxide from my original 2 grams of calcium oxide added with a little bit of water. There we go, 3 marks. Good luck, get practicing. Remember, we're talking B MAMRU for any question that talks about calculating the mass of an element or a compound needed to be produced from the mass that they've given you of a different chemical. Remember, the clues will be in the question. It's always worth 3 marks. There'll always be a balanced equation somewhere on the page or at the start of the question, and it's probably going to give you the atomic mass or the formula mass of some of the chemicals involved. Good luck, happy revising.